Hello everybody, hope you are very fine. We are very happy to have you today on this webinar about point cloud. Please note this webinar is being recorded, and also you can write all your questions. We will try to reply all of them during the webinar. And if not, we will send you a personalized email to give you the specific reply to your questions. Today with me is Antonio Pardo and Jorge Cabanas, both of them AdriaBIM teams that each one will show you part of MDT, part of point cloud modules, and a surprise about a new software coming called TCP point cloud editor. Okay, let me quickly introduce AdriaBIM, as I suppose most of you participating already knows us. Okay, so AdriaBIM is a Spanish company based in Malaga in the south, and we are software developers for surveying and civil engineering. We have a huge expansion internationally with more than 15,000 users licensed worldwide, and we work through exclusively distributors able to give you a first local support. This is one of our main success, but also particularly because our licenses are permanent, easy to use, and a very competitive price. Another big point of AdriaBIM is our very recommended after-sales services. We have a very high-quality technical support giving you the specific reply to your needs. We offer a different kind of training from basic to advanced, and also I really invite you to put in YouTube AdriaBIM. You will find a lot of video. Even if you find them in Spanish, you can go to subtitle because all the video are with English subtitle, but also we have different languages available. Some quality certification about our quality, like ISO 9001 or Innovative SME. And one really important point is a clients and distributors survey, which allow us to have always the specific tools for your needs. Some innovative project. You have to know that we work so much for public and private companies, and we invite you to discover all these investigated projects because we believe they are really relevant for the surveying market. Some universities and associations at international level, we work with LandXML, which is a generic format of exchange between one software to another one. The Building Smart with the OpenBIM format. AdriaBIM is very involved on the promotion and the divulgation of the BIM format. We have already commenced to work on to export in IFC, like superficie, alignment, and this kind of things. And now let's start to work to know a little bit about our know-how. What are able to do our software, like managing an urbanization, quarries, mining, tunnel. Firstly, you have to know that our development partners are so much working on Android, Apple, S3, Intel, and Microsoft, which allow us to be CAD cross-platform. Our software, like MDT, we will see, is a plugin who need a CAD. So we are working on AutoCAD 21, RiskCAD V20, and ZVCAD V20. We have also some brands agreement. We work with different companies that give us their last instrument in order to be compatible with their total station or laser scanner. AdriaBIM is for family software. Today we will have a kind of mix because our module point cloud is also very used in the photogrammetry sector, but MDT is about surveying project. We have also software for tunnel and software for field to work so much on Windows than Android. Our current research area are actually point cloud, and as you will see, we will show you the new software coming, point cloud editors. augmented reality, drone, and BIM for infrastructure. Some national reference, we work with the main Spanish contractors like SACIR, Acciona. We have an agreement with the highest university of Spain. And at international level, we have great project like Panavial, which is a highway who will cross the east part of United States from north to the south. With part in Canada. Actually, we are working in Panama, Colombia, part in Ecuador, and this kind of things. The underground of New York or Riyadh, and we include some project in Africa for managing quarries and this kind of things. And thank you very much. I will now let hands to my colleague Antonio Pardo to start with a live demo that I Okay, just 1 second, make presenters. Antonio, can you share your screen?
Yes. Can I hear me?
Yeah.
Hello, everybody. Hello, everybody. Today, we are going to show how to work with point cloud application from Untitled family. Now, this is only to say that this application was born due to the fact that there are many massive data acquisition devices that allow us to get a dense point cloud easily, like a laser scanner, even total station, drone flight, or another way, the LIDAR sensor, no? Okay. Well, the first of all, we are going to show how to organize the application, okay? In this case, we have a little example, okay, on this area of work, okay? Only to say that the application are organized by 3 tabs mainly. The first one, home, is only to setting up the different parameters in the application, like a color, languages, etc. Okay, like another kind of application. But mainly, the second one, and the third one are the mainly tabs that we can offer. Applicator offer us different tools to manage the point cloud. The point cloud tabs offer us how to work with them, for example, to load, to import, to export, to filter different cloud of point to create a new cloud, to show the property of each point cloud. Okay, in this window we can show the different point clouds that we can work. Okay, we have loaded there, and we can work with them at the same time. Okay. The second tools offer us to cut or to trim one point cloud to cut in another point cloud smaller to work with this easier. Okay, it's a one kind of work. We select the limit, the boundary limit. Okay, to cut. Okay, it's easy to work with this. Okay. We are going to the set, okay, and now we have another option to visualize the point cloud, like orthoimage is this kind of view, okay, or in this case we can use a perspective view like this. For me, I like to match this kind of view because it's a realistic view of the terrain. No, it's very easy and very practical. Now we can hide or visualize at the real time to show the grid 3D of the boundary of the point cloud, to show the limits there, or even the target show. Okay, to show the target where we are going to see. Okay, and now different tool for selection the point. In this kind, we can select point by point or by rectangle, polyline, or even the last way, the 3D box, define a 3D box, okay? We can change and selecting one area that we are going to select, okay? It's easy way to work with this, to maybe to hide, for example, hide this part of the point of cloud, etc. Okay, it's different to this way, to extract this way, because in one way to selecting the point that you want to work, and another way you extract only the selection, okay, by filter that you have here, okay, that you get a new point cloud. And finally, we could represent the, I'm going to restart everything. We could represent the point cloud in different ways. For example, in this case, it's a natural color. It's this option, okay? Natural color. This is the color of the point cloud, okay? Or we can use a gradient color if we have the point cloud from the sensor, the LIDAR sensor, for example. We can see, or we can watch the gradient, the intensity of each point, okay, or by color. In this case, is not useful for this example, but we can use too the gradient color by height, okay. I'm going to click on there. Show the palette of the color between the minimum height and the maximum height, okay, and show the color each point depending on the height. In this case, you can realize the catenary, the cable of the electrical cable that they are here in the real trench, no? It's easier to weigh. And finally, we could represent by category. It depends of the sensor, or maybe in this case, this sample was tinted by Dronefly and processed by Pix4D. So we can get the different categories from each point, okay? We can show each kind of category. We can show this category, okay? We can see different category here, okay? How to represent the point cloud. It's only to show or how to demonstrate the point cloud that we are going to work, okay? This is this tab. Bueno, I forget to say something about the current point cloud. For example, the property, in this case, it's a point cloud that it has 16 million of points, and this is the limit of the boundary of the point cloud, and the attribute that they are that natural color, like I said before, and the category that it works. For example, I can show the vegetation, I can the building, the ground terrain, etc. Okay, good. I think the most important thing of this application is the Tools tab. Okay, these Tools tabs are defined or are created in the same way that we work with MDT. So we are used to work with this kind of tools. For example, we can work with horizontal alignment, we can get cross-section or profile, or we can create a surface, a grid, etc., and contour line. The most important thing is easier for us to exchange information from MDT to point cloud or vice versa. For example, we can send a surface, a grid, or contour line to MDT or another way around. In this case, I'm going to follow one small example. Okay, from this real trench, okay, to analyze the slope. Okay, I'm going to exactly like this. I'm going to analyze the slope by cross section for each cross section by cross section. Okay, for that I'm going to get different cross section from different way in this example. Okay, now I'm going to create a horizontal alignment. Okay, for that I'm going to use the MDT. In this case, I can show you the ortho image of the same work, and where I have drawn all the entity, the linear entity, like a fence, like a pavement, like a wall, etc., or even the tree or the vegetation. But now, we need to work with we need to create a horizontal line that we are going to use this real line. Okay, this line I'm going to convert to horizontal alignment. Okay, now MDT alignment, convert polyline to alignment. Okay, I'm going to create an alignment. I'm going to name, etc. Okay, I'm going to save here to replace the another one. I'm going to show dimension the alignment. Okay, and here is. Okay, if you see there, the new alignment that we are going to send to point cloud to analyze the real trench. Okay, now if you look on the top, we can find the menu of the point cloud where we can run the point cloud. In this case, we already started, because to load the point cloud maybe it take 3 minutes or something like that, to avoid to waste time. Now I'm going to send align. It's easy way only to click on send alignment and select the alignment. Okay, select the alignment and open the point cloud. And here is, can you see down. Okay, in this case is button is on the bottom. Okay, we can change the position. Is only for representation the horizontal alignment, because there isn't any information about the height. Okay, now we are going to change the position, for example 50. Okay, here we can see better. Okay, I'm going to change the target of view here here to see better. Okay, okay, it's better, no, to check the alignment around the real trench. Okay, now we are going to use the tools of point clouds. Now we are going to use the cross section, for example. Cross section, we can define the different parameter. In this case, the interval, the cut interval, to get the cross section, the width of the band, 20 meter and 30 meter at right. The most important thing, I think, is the regression strip. This is a big important concept to understand how to get the cross section of the profile. It's only to get one band of the point from the point cloud that they are going to project in the cross section. Okay, like a point, the same thing like a point. Okay, I'm going to show how it works. Okay, now the editor of the cross section turn up, and we can run along the axis to show the different cross section of the work. Here we can check. I'm going to check now. Is a typical cross section here. For example, this is the roof of the building, the wall. Here is slope, the vegetation there, the electrical post, how to hold the cable, the electrical cable catenary from the real, the each real rail line, for the fourth real line, a bit channel down, okay, the slope, the right slope, a lot vegetation to cover the slope, okay, and it's a good tools to analyze a different slope here, okay. We can show different along the alignment, no? Okay, I said before, if you realize always are points, there isn't any kind of line that we are used. So we can convert this point, or we can work with this point and convert automatically to a line. For example, we click on create a longitudinal automatically, and we are going to say the criteria. We are going to use the minimal point, the minimal height, and we are going to put one vertex each 20 centimeter, okay? And here is, we create a polyline along the cross section using the minimal height, okay? And for each cross section we have a polyline that we are going to use to compare in MDT, okay? In this case, we use all the point, the natural point, okay? So now we are going to repeat the same workflow to get the same thing, but only we are going to filter the point by category, okay? I'm going to copy, I'm going to export in MDT format, accept point, 1 point, okay? Save, okay. I'm going to repeat as I said before, but in this case, I'm going to use only, I'm going to delete the vegetation, okay? I only do use the ground terrain, the building, and the rest of the category, okay? Here is, and here's the new point cloud, okay? Without vegetation. Now I'm going to create a cross section, repeat the same parameter, okay? And I'm going to show the result, okay? It's the same thing like before, okay? I forget before to say that we can reduce the point here in the how to show the different point, or even we can take a picture for each profile to send to MDT to analyze easier, okay? Or maybe we can send directly each cross section by like a point cloud, okay? In this case, we send the points and the format of the cross section. But we prefer, or I am used to work with line, and I'm going to create the same thing, 20 centimeter, okay? I'm going to create the cross section by polyline. It's easier to analyze and to compare different ways of the cross section, okay? Okay, I'm going to close. And now, later I'm going to show the different way in MDT, but before I'm going to show how to create a surface here in point cloud application. For example, I'm going to create a surface. In this case, only we can define two parameters: the minimum distance between point and the maximum size of the triangle. Okay, we are going to let that parameter. I'm not going to abort that command because it takes about around 2 or 3 minutes. I'm going to abort. Okay, yeah, I'm going to show because I have already loaded. Here it is. Okay, this is the triangulation that we get when we triangulate the point without vegetation. In this case, if you realize there are some error that we must to edit maybe or delete some point and repeat to create the triangulation, or maybe we can send the triangulation to MDT and edit in MDT the triangulation, okay? In the same way, we can create the grid, okay? We can create the grid. We define the cell size, 1 meter, and the same time before, I'm going to abort the comma. I'm going to show, okay? I'm going to show here. Now we can see both of them, the triangulation, the grid, at the same time. Okay, I'm going to hide the triangulation. Okay, it's easier to work because we can hide the point cloud, or we can show the point cloud in different natural color directly. Okay, or we can directly hide the grid and show the triangulation. No, now we can create the contour line. Okay, we are going to use in this case the current surface. Okay, and this is the initial parameters. Okay, okay, by 1 meter, and here is the contour of this work. Okay, if we realize the work, for example, we can only show the contour of the work. Okay, now I'm going to send this triangulation, this surface, or this grid to MDT to get the profile and compare with the another one. Okay, pues it's something so easy like that. I'm going to send in that work, okay, in that drawing, I'm going to send the information, surface, for example, send to MDT the surface. I'm going to open, and directly it's exported the surface, and I'm going to set at current surface in that drawing. Okay, and here it is. That is the surface before. I'm going to get the cross section, the same thing. Cross section here. Get cross section. I'm going to use the horizontal alignment carefully. Okay, I'm going to say where we are going to save that cross section. Okay, to replace in the same parameter. Okay, and there is. Okay, all the cross section here from that surface. And for the grid, I'm going to create a new drawing. Okay, and now I'm going to export the grid. Okay, to send the grid. Now open, and the same thing, set as current surface. Okay, and here it is. We can view directly, for example, 3D view. Okay, and here it is. Okay, this our grid that we create in point cloud, and we are going to repeat the same thing. Cross section, get cross section from the drawing. I'm going to choose the horizontal alignment. Okay, the same parameter. I'm going to say where we are going to shave here. Yes, the same parameter. Okay, and there the same thing, no? Top here. Okay. Now we are going to compare this kind of the cross section. For that, MDT cross section, drawing face, and we are going to choose each one of the cross section. The first one, the category, from the grid, and from surface. Okay, and now in the editor cross section editor, we can compare each one to see the similar difference that there are by different ways. Okay, in this case, I think the better solution is the blue thing, the blue color. It is the surface that we get from the surface by categories. Okay, but it needs to edit before in MDT, for example. Okay, now we can go to draw directly. Okay, we are going to check and go to represent the cross section. I hope you enjoyed with my demonstration. As you can check, it's very easy to work with point cloud to how to represent or how to show the different point cloud, and the more important thing, how to extract information to work with them. Okay. Now I'm going to hand you over with my colleague Jorge Cabanats to explain or to make a demonstration point cloud editor.
Hola Jorge, ¿estás con nosotros? Perfecto. Hello Jorge, we don't hear you.
Hello?
Yes.
Now?
Yes, please go ahead.
Can you see my screen?
Yes.
Okay, hello. I'm Jorge Cabanas, software developer at Appletop, and I'm going to show you a short presentation of and a few videos that demonstrate the features of TCP Point Cloud Editor. Some parts are cut or accelerated due to time needs. So we start the presentation. The objectives of this presentation are because a series of facts that there are nowadays, like the availability of point clouds coming from different sources, like LIDAR point clouds or fixed and mobile scanners or photogrammetry applications. Our users demand new requirements due to the large amount of information of the point clouds. Our users are also focused on surveying and civil engineering, and we need a tool for managing and working with this kind of information. We try to provide a tool that offers different editing and filtering options for the point clouds and ways to work with these points and create different products. Other objective is, as always in Appletop, the easy to use of our applications. The main features of the TCP Point Cloud Editor is the point management. We can import the most common formats, standard formats or proprietary formats from different scanner makers. We also provide a transformation and point clouds alignment, and we are able to represent the point clouds in different colors based on the different properties of the point clouds, like intensity, category, or whatever. We provide also different editing tools for selecting in different ways, for hiding or removing selection of points, and also to change the categories of the selected points. We will see this in the demonstration. We also generate profiles as MDT point cloud does, and we can import or draw alignments. We can generate profiles and cross sections using those alignments, and we have developed powerful editors with many features to work with alignments. In the same way, we offer many tools to work with surfaces and grids. We will see that we can edit grids in different ways, and also that we can show or render on the screen these grids in different manners, so the user can appreciate the grid that has been generated. Also, we offer basic CAD functionality, and we full support DWG or DXF file formats. And at the end of the video, we will show how to generate a video of a tour around the point cloud. So let's go. The advantages of this product for users in general is that this is a standalone application. It does not need a CAD application, but it's developed in order to support MDT. We can generate high-quality products like surfaces and grids and profiles, and we can import and export data in different formats of point clouds or grids like land XML. We can import and export orthophotos and things like that. For the Appletop users in particular, this product will be a replacement of MDT point cloud module that Antonio has explained before. It has a new and increased set of tools. We have developed a lot of new tools to work with point clouds and also with grids. The results will be better compared with MDT point cloud, and we think that is the optimum combination to work with MDT. As always, the results that are exported are fully compatible with the other Appletop applications because it uses the same file formats. So let's start with the demonstration. I'm going to show the demonstration here. Okay. Yep, this is not. I'm going to show you now the videos. Let's start with the first video. In this video, we are going to see how to create a new project. We only have to set the file and folder where the project will be created. And now we are going to import the same point clouds that we have seen in the previous demonstration by Antonio. We can see that our application can import a large list of file formats from Topcom, Leica, Regal, and standard formats like LAS, for example, in this case. We have different options in the way the import process will be done. We can filter by properties or by the limits of the coordinates of the point clouds. The process of import needs some time. We have put some part of this video, and we will get now the results in the bottom line. We can see what the application is doing, and we get the import results and a table with the boundary limits, the number of points, and also a summary of all the point clouds. Now we can see that we can apply different options to the point clouds we have imported. We can see the properties, and also we can, for example, change the color we are rendering the point clouds. We can set a single color for each point cloud in order to differentiate each one. We can see that we have a LAS point cloud and a small point cloud that was generated by photogrammetry. We can appreciate here, for example, by 8, the difference of density between the point cloud from photogrammetry and from LIDAR. As previously we did, we can see in RGB, and we can also show the point clouds using the intensity. The photogrammetry point cloud does not have intensity information, but the last point cloud does. We can also, as in MDT point cloud, show the point clouds by category, where we can set the visibility of each point cloud and the categories, and we can also set name and color for user categories in order to organize the point clouds or the way the user prefers. Now we are going to focus on the photogrammetry point cloud, and we can see how we can select in different ways the points. We have many options. We can select by circle or rectangle. we can select also by a polygon, where all the points inside the polygon we draw will be selected. It will include the previously selected points. With the selections we can work removing them or hiding them, as we can see later, and also we can use selections to filter and to focus in an area of the point cloud. For example, we can see here that the category of this tower is brown because it has assigned different categories like high vegetation or building. We are going to filter those points in order to work better, because we will see only the selected points. And now we are going to select the tower in order to change the category of those points. We select the points and select the tool to change the category, and we have all the last categories available, and we change this category and we can see that the color has changed. So when we export this point cloud, those points will have the assigned category. This is a useful tool to edit manually the point cloud and to change the categories. Okay, now I'm going to show the next video. This video is about grids. We are going to create a grid using the points of the point cloud. We set the parameters like the boundaries in X and Y, also the cell size or interpolation distance. We have options to fill holes, for example, or to interpolate edges. The grid we have generated is added to the project, and we can inspect it and show it in different ways, by age or by phase, and changing the color based on the age or the slope direction, as we will see now. This is the options of the grid representation, and also we have implemented lights or lightning effects in order to appreciate better the ground that this grid represents. We have implemented also a level of detail view in order to watch a most detailed grid if you get closer to the grid, and a road grid if you go farther. Now we are seeing that we can change the representation by age and select the color palette that will be used. We can also show it by slope or also by slope direction. For each representation mode, we can select a different color palette, as we can see. And now we can also see what we will get if we turn off the illumination effect. It will be flat, so we cannot see or appreciate very well the grid if it's with faces. We also have a visual effect that is for contours. It generates automatically the contours, and we can set different parameters for major and minor contours in order to view how soft the grid we have created is. This tool also allows us to appreciate if there are peaks in the grid that we will be able to edit. Now we are going to edit the grid. The first tool we are showing is the rule grid, where we select an area of the grid that we know that is brown, maybe due to the vegetation, and we have different methods to change the grid. We can apply this operation, or we also may undo the operation if we have a wrong result. Now we are going to see another tool for editing grids. This time we will use the set terrain. This tool allows us to define a segment or direction and set also the left and right distances, as we can see here. The user set both left and side distance over the grid and also sets the bandwidth. We will generate a cross-section, and in the cross-section editor we can edit the different sections that we have generated. This tool has many options for editing and viewing. For example, we can see here each cross-section and the previous one. This is useful to edit the cross-sections that we generate. We can edit them removing vertices, or also drawing a new segment, and the cross profile will use this segment to create the cross section. Using those cross sections, the application generates a part of a new grid that we can add to our project. We can appreciate that the vegetation noise has been eliminated from the cloud. Now we can use the merge grids tool that will replace in a grid that we had part of this grid with the grid we have generated with the set terrain tool. Now we can appreciate that the terrain is better now and is more accurate and close to the reality. Next one, we are going to show the alignments import, where we can also import the vertical alignment in order to watch how this alignment is. We can see that each alignment is in different color, the straight lines, curves, and clotoids. With the imported alignments, we can also generate profiles and cross sections. We only have to set the initial and final station and the left and right bandwidth, and when it's selected, the points are collected from the point cloud and sent to the profiles editor. As we can see, we have here all the points that are inside the bandwidth along the alignment. The same thing we can do with the same alignment for generating cross sections. This will generate all the cross sections, and we have more parameters this time. We have the cutting interval and the left and right distance to the alignment in order to generate all those cuts of the point cloud. Once the alignments are generated, the cross sections editor is open, as we have seen before, and we can appreciate that the point clouds of each sections are created, and we can move forward and backward along the alignment. Okay, next one. This time we are going to show the tools that Point Cloud Editor offers in order for measuring tasks and for drawing also. We are going to work in a part of this Point Cloud is a building, and the first thing we are going to do is to measure a distance between two targets that are present on this facade of the building. For this task, we pick in the center of each target, and we get a line joining both points with the distance between these 2 points. We also have a tool for measuring the distance in 2 dimensions and also the X difference. As we can see, we have a triangle where is the X and Y distance and also the Z different. We can remove these measurements. And now we are going to restore the full point cloud. And we are going to show the drawing capabilities of this application. We have a layers manager where we can create new layers or remove the ones we select, and the lines or points we draw will be added to the current layer. Now, for example, this is a small example. We are going to draw 2 closed polylines, and we see how the polylines are drawn over the point cloud. We do the same for this other part of the point cloud, and we will see that we can also use the application to draw using other elements different from the points of the point cloud. For example, we have reference to entity, to final, mid, or closest point. So we can create new lines joining entities vertices. We can configure the options of the layers in order to change the color or the line width of each layer. Now we are going also to import a new drawing. This drawing was created with this application also, where we have several layers like different facades, the windows, doors, the roof, the ground. So we can see that we can inspect in 3 dimensions the drawing. We can remove the previously created layers, and we can set the visibility, for example, of two of those layers. We can see that we have the windows and the doors, and we can see how those the drawing falls over the point cloud. Now we are going to show also other option using alignments. We can generate a quick profile of one of the facades of the point cloud, and we will get in the profiles editor an image of this facade of the building. In fact, there are only points, but when you see those points from far, you see an image. We use this in order to export the image to a JPG image, and we can set different options in the export process. With this image, we can use MDT to import the georeferenced image in order, for example, to draw a polyline using the image as a template. For example, we draw a polyline in the contour of this part of the building, and we can remove the image, and we can see the result we have, and it's georeferenced in 2 dimensions. Now we will show a job that a workmate did previously, where we see all the facades of the building with the dimensions of each facade. When we get closer, we appreciate that our points is not a continuous image, are the points of the point cloud projected to the plane of the profile. Last video is about alignment of point clouds and video generation. For transformation of point clouds, we have different tools. One of them is this one, is translate and turn point cloud, where we select two segments that are the same but in different places. We only need to give the origin point and a direction, and this tool will create a transformation and calculate the transformation parameters. Once we get these parameters, we can choose the point clouds that we want to transform using this transformation. This process also takes some time because this point cloud, for example, has 200 million of points, and once it's transformed, we get a new point cloud in our project with a given name. So now, using the single color option of representation of point clouds, we can check that both point clouds are the same. The transformation was okay. And this is the last feature we are going to show today. It's about video generation. We can set several waypoints, and the application will calculate a path along these waypoints. And when we set the configuration options of this video, the application will create in the path we select a video. The video also takes some time because it has to generate a lot of frames, and we can see here an example of how the resulting video has been. We can set different options like speed or frame rate and other more waypoints or whatever. We can go back and change the options if the resulting video is not okay. So that's all the presentation, and I give to David the control of the presentation.
Grazie. Thank you, Jorge, for your time. Quickly to follow up, I will finish our presentation saying that in our web page, if you are interested by our software, you can go to the section products, look for point clouds, okay? And inside you will find a lot of information as some videos, but also you can download the dossier, request a quotation, or a free trial versions. Okay, just would like to finish my presentation by saying you point cloud TcpMDT has two versions, from standard to professional, with 3 modules: image module, surveying, and the point cloud modules. Here is a resume about what you can find in each part of TcpMDT, like in the standard version, manage points, make your profile and cross-section. Professional version is particularly useful when you want to design horizontal and vertical alignment, and make also some kind of volume reports or this kind of things. Surveying is when you want to, when you work with a total station and you want to make your transverse or networks or processing. There is some geodetic calculators to transform from one datum to another datum. Image module is about to work with orthophoto, to download some photo and apply them as my colleague Antonio has shown, and the point cloud as you have seen actually. Remember that for working with the point cloud, we work so much with Leica scanner, Faro scanner, the generic format E57. We work with LIDAR like LAS and LAS, S3, polygon 5 format, and generic format or MDT format. As you have seen, this is all the point info, color intensity and category, and some options. It needs technical needs is a Windows from XP to 10 in 32 or 64 bits. and it is compatible with all these CADs, okay? BricsCAD, AutoCAD, and ZVCAD. Just to finish, for those who are already interested to TCP point cloud editor, you have the possibility, MDT point cloud is already available, so don't hesitate. TCP point cloud editor, we don't know actually when it will be launched. We are still in the final phase of development, okay? But it is possible to make a free exchange from if you buy now MDT point cloud, you can exchange it for free, or if you want to keep it, your CAD connection, you can keep both applications and you will get a specific and very special price for the point cloud editors. So this was the point that I wanted to precise today. Thank you very much to your participation, and we stay at your disposal for any question you may have. Thank you. Bye-bye.